Welcome back. This video will be on how to set up your computer for Cyberpunk 2077. Our test machine is this machine that I built a few years back. It's a GTX or RTX 3080 12 gigabyte, 12,900K that is delidded in there. And the MOSFET banks, the two MOSFET banks for the CPU, have additional heat sinks, and this was the main purpose of this video, is the heat soak that Cyberpunk generates. Our cooling system is a little bit complicated, but I'll go over the parts. We have a 240 millimeter pump. It's a 1500 liter per hour pump. We have the memory cooled, we have the CPU cooled, we have the graphics card cooled, and we have the PCH. The PCH has, I think it's like a 90 watt heatsink from a laptop, and then I have the same type of heatsink for one of the SSDs, which you can see right here. As far as the radiators go, we have a 360 millimeter on top. We have a 360 millimeter double thickness right here, so back there, and then we have a 360 millimeter here with a 240 millimeter on top of that, so it's a double cooling, which is kind of experimental, but it seems to work pretty good. It adds a lot of capacitance, which is a good thing to have. And then if we follow the tubes, we have the two input-output tubes going to this system right here outside, which is kind of complicated, but it's a 480 millimeter radiator, which is like regular thickness but double finned at the bottom. And then we have this 360 millimeter just generic radiator, and then we have this double thickness 240 millimeter radiator with 550 CFM each fans. Now this part does not have a fan, but we have regular 77 CFM fans, 4 of them down here, and at the bottom, which I'll show in a second, we have 4 server fans. For this video, I'm not going to be running the outdoor radiator for the actual purpose of setting up your own machine for Cyberpunk, but this radiator setup is basically the reason why it exists is Cyberpunk. Just overclocked 24/7 numbers, so that's what it looks like. And let's get back to the setup. Now, with this setup, I mainly built this to set world record overclocks, and I have a bunch of them. I think I have like 170 world record overclocks with this outdoor radiator setup. It is about 65 degrees outside. We could turn it on and get some super cold numbers, but I wanted to show the absolute opposite of that, which I've tested in the last couple days. Which I will show later in the video. But I wanted to show my BIOS profile. So I have a bunch of BIOS profiles, some to set world records, some to set just reliable numbers. Let me put this way. So the BIOS profile we're running right now is 5.4 rock solid. And basically, it means that don't touch this BIOS profile. I do a lot of experimental stuff, but basically, this 12,900K runs at 5.4 gigahertz on all of the cores all of the time, which means it draws a lot of power all the time. But the E core is at 4.2, and the game never actually utilizes the E core. Only the Windows applications do. So E core is something that you can, some of the professionals disable it, so we can skip that. But 4.2 is very high because the stock value at maximum peak is 3.9, but 4.2 is fine. I have the cache set. The cache is basically what communicates between the CPU, and the memory. So you can clock the cache very high, but then the memory can be unstable, so it's not a thing that you really want to clock super high. But I have had this up to 5.1 gigahertz and it was still fine. But this is a reliable setup, so it's 4.9 gigahertz, which is still pretty high, and I will explain that in a second once we get to memory. But I wanted to go over voltages first. And we have super high voltages set up on this machine, mainly because of the cooling capacity. But we have 1.47 volts on the core at all times, 1.44 on the E cores at all times, 1.44 on the system agent, 1.47 volts on the memory controller, 1.44 on the secondary memory controller voltage, and then we have some other voltages that it has taken hundreds of hours to get to, but they're not super important because everyone runs different hardware. The secondary voltages is the memory. So we have 1.54 volts for the memory voltage and the VDDQ. So they kind of work together with the CPU memory controller voltage, so they kind of have to be similar. Now on to the memory. The memory is basically the hardest thing that you can work on a computer. It's very, very complicated and there's not much information about it, but that was mostly the reason, besides the cooling capacity of this computer, the reason of this video is to explain the memory, because it has taken me years to understand how to do this, but I will try to explain it to my best of my abilities. So this is B-die memory, so it's very good, and it's also water cooled, which means that there's some technicality stuff, but not just the memory chips, but there's a controller on the memory stick that is usually not cooled. And basically, even with low voltage, that thing is not cooled. It's not touching any sort of metal contact. So it gets up to like 105 degrees Celsius and is usually the bottleneck for setting memory clocks. Mine is double padded on each side. It's overkill. So my computer is overkill on the heatsink, the cooling capacity part, but I will go over some of the numbers. So it's 6600 megahertz DDR5. Now I have the main timings are 30, 38, 38, 38, which is pretty tight. And then the RFC is 280, 280. And I'll put an image of the timings that I have, just so you can copy it if you want to, but you will need a cooling setup similar to mine for it to most likely work. But the main thing, after the hundreds of hours of research that I've done, this is what I want all of you to focus on, is that the only two numbers that actually matter with DDR5, like basically you can set all the other stuff regular XMP profile or just regular basic BIOS defaults, but if you set these two for the number 8, you get all of the performance. There are 3 main things that I want you to test your machine with before you decide that your computer is stable for Cyberpunk. The first one is Cinebench R23, so we'll launch that. And now this is without the outdoor radiator turned on, so the processor is technically limited to 500 and some change watts, so basically it could just crash if it wanted to. But I will show you how I do it. So I have core temp. Core temp is also, so I guess that's like 4, but like core temp is something that always runs, and it shows you in real time what each core and e-core is doing. But normally what I do is I set this so that we're going to do multi-core, and if you do File, Advanced Benchmark, turn off the limitation. You don't need to run it for 10 minutes, because like if your computer's stable for 10 minutes, it most likely means that your computer has way more potential. So just set it for off, which means that for one single bench press, it is fine. So right now, the water temperature is 28 degrees Celsius. So we're going to do multi-core, and then we're going to open up core temp, and I'll pull this over here. So we're pulling 370 watts, still running fine. Our maximum temperature is 100 degrees Celsius, which is actually pretty good. It sounds weird, but I don't know if you've ever seen a 12,900K die, but it's very, very small. But there we go. So it completed it, and we got basically top 1 percentile numbers. We got 29,811. There are numbers out there that are way higher, but they're doing liquid nitrogen, and I like 24/7 reliability, so that is kind of the point of this video. So it passed the first test. The second test is 3D Mark Time Spy CPU. Now, you can use different 3D Mark CPU platform tests, but I find that Time Spy CPU is very good at validating errors, because it's fast-paced, and it gives you a very good CPU memory stability and speed validation. So there we go. Also, just even launching 3D Mark, so now we're at 90 watts, and that's going to turn into a peak pull. So 300 watts for a second, computer still didn't crash. And this profile, this BIOS profile of the memory and CPU is good for 66 degrees Celsius water temperature, so like it won't crash. And basically that took me 17 years to get to. But with this video, I'm trying to explain how you can get to most of that as quick as possible. So in 3D Mark, which is a paid program at this point, you disable the graphics tests, because you want to deal with memory and CPU separately than graphics, because if you try to like validate all of them at the same time, it's gonna be very hard to diagnose. You want to do one thing at a time. That is always, even in business, like one thing at a time. So we're gonna do CPU test, and we're gonna disable on-screen display of the Riva Tuner statistics server, because that does affect the test. But here we go. So, and when this starts, it does also peak the CPU to maximum, including the memory. So it's a stability test of its own, but let's see what number we get. Okay. Alright, so we're at around 100. Now the dip comes in, and this is where most computers crash. So, okay, so let's see. Alright, 22,000. So normally this profile gets 22,500 to 22,000 flat, which is a very reliable setup. This test is not reliable, so getting similar numbers over and over again is perfect. CPU and memory testing and benchmarking is a very unreliable thing because they're combined. But as you can see with the graphs, CPU clock is straight. I guess that is graphics clock. Yeah, so that is, disregard that. But CPU clock is straight. So we're good. We have 22,000 points. And I know there are more powerful CPUs out there now. But again, consistency is better than just peak performance. 22,000 is perfect for this monitor. On to test number 3. So now this goes back to memory, and again, you will spend a lot of time with memory because it is not. I guess it is humanity's ultimate challenge. But what I use is testmem 5, and I have it on extreme so that it just stresses the computer out as much as possible. So I'll start it here, and basically with the numbers that I have for the memory, this does pass, and it passes even when the water temperature is high. But this takes about 30 minutes and is very stressful on the memory, and it sometimes does damage the memory. But this is the only single true thing that actually proves that your memory is fine. But we'll go back to cooling in a second, and I'll explain how that combines with this test. Now, if I turn back Riva Tuner Statistics Server on and I launch Cyberpunk, you will see kind of what I'm talking about. So you see that it's already spiking the CPU to 220 watts. Now it's calming down, but that is also a very common thing. Like Fortnite doesn't have a limit. Most games don't have a limit anymore. They short circuit the CPU, which is a very inefficient manner. It's almost like torque squeezing the transmission drive of a car. It's yes, it is stressful and it's going to make it the most torque, but so here we go. Okay, so the game is loaded, and we're pulling. So after all of that stuff that we've done, this is the final result. And I'm gonna go over graphics settings next, but we have CPU running at around 35%. And don't worry about the CPU percentage because it doesn't. So it's not saying, it's just saying 34%. Oh, most likely P cores. So it's not really saying anything about the cache and any of the other parts of the CPU. There's many parts to the CPU, but the end result is that we're currently getting 138 FPS, and this is a 155 FPS monitor. And if you watch YouTube videos, you see the minimum frame dip. But with this computer, that's what you get 99.9% of the time is basically the maximum refresh rate. And that's the point of this video, is to get you to that point and be able to run this game right as it is right now, 24 hours a day, 7 days a week, without it crashing, which is the ultimate reliability of a computer. As you can see, the GPU is utilized 100%, which is perfect. That is the end goal of what the CPU and memory is supposed to do. And I understand this is only a 1440p monitor, and it's not ray tracing, but it is perfect. You can actually enjoy the game without worrying it having to crash. while getting maximum FPS. Now, as our temperatures are rising, and as I said in the video, I've actually tested this up to 78 degrees Celsius water temp. I put boiling water into the water loop, and it still didn't crash. So these clocks are, it's been a 3-year journey of getting these clocks to work, but reliability, so it's reliable. But for something that is not ray tracing, these are the graphics settings that I use. Now, I don't change these graphics settings that often, but I just want to show what I run if you have something similar to a 3080 or a 3070. DLSS definitely reduces the power consumption, so I have it set to quality, and I have it set to 0.75 sharpness. I didn't find any performance reduction or increase by changing that, but 0.75 makes it closer to the true resolution. And this is 99% of where the performance decreases or increases is the screen space reflections quality. Now you can have this at high or ultra, or I think it's insane, but I just keep it at high, and it greatly keeps the GPU at close to 99% utilization rather than reducing the FPS. For the rest of the settings, I have it at high. I don't have ray tracing on. My graphics card, like I said, is a 340 watt graphics card. It's not capable of really doing ray tracing at a reasonable level. I prefer having close to maximum refresh rate FPS. So these are my settings, and I highly suggest that the only real setting, so you can max out everything, the only real setting they need to set is the screen space reflections quality. So that is what consumes the most power. I just have it at high, and visually speaking, it's best to just have it at high rather than maxing out and having your FPS reduced, because then you're just having less. So that's the end of the video. I have tested this game at these settings with this computer profile and clocks and cooling system for a couple hundred hours, and basically it just means that I can have the fans killed, which, let me show that. So the way I tested this to up to like 68 degrees Celsius water temperature is that I have a kill switch for the internal fans, and right now we're only running the internal fans. There's 3 fans back there, 3 fans up here. But if I turn that off, this turns into a space heater. So that's off, and now the computer's just heat soaking. But I've gotten this up to 68 degrees Celsius. And yeah, these clocks, they run fine. This is basically dollars to dollars. It's a 12,900K with a 3080 12 gigabyte. It's basically a $1,200 computer, so you don't need this cooling setup to make this happen. And this is like a $400 monitor, but and this monitor is a little bit overpowered for the computer, but it still runs fine. So I guess I hope this video better explains what you need to look out for while playing Cyberpunk on a reliable level. Thanks for watching.